Are you ready for the physics class, children? And we have discussed a beautiful and surprising concept of friction, that it is a self-adjusting force. It is a lazy boy. It just finds if 1 Newton force is sufficient enough to keep the two surfaces together. Even if it has its maximum possible value which it can attain, 10 Newton, it will adjust itself up to 1 Newton only. Now an interesting example, right? And here I have taken 3 cases. In all the 3 cases, I have taken a block of 1 kg. And this is a vertical wall, as you can see. Vertical wall. And I want to fix this. I want to keep this 1 kg block sticked with the wall. I don't want let it fall down. What should I do? Well, you will also say that I should exert a force towards the wall like this to keep it at this position sticked. Alright, in all the 3 cases, I am exerting force to keep the block sticked with the wall and remain in equilibrium at its position. Now let me take 3 interesting values. This is 1 kg block, okay? So, the gravitational force which is pulling it down, it will be 1g, right? That means 10 Newton. 1g means 10 Newton. And here also the gravity is pulling it by the force 10 Newton. And here also gravity is pulling it by the force 10 Newton. So in all the 3 cases, gravity is pulling it by the force 10 Newton, right? Everybody agrees with me? Now I exert force here, say 10 Newton. Now remember, what are the factors on which frictional force depends? On which frictional force depends? I am writing it here. Frictional force depends upon material and normal reaction force. We have discussed it in the last class. Material decides, and material is represented by this coefficient of friction. Coefficient of friction, right? Now say coefficient of friction of the wall is here also 0.5, here also 0.5, and the third case also 0.5. And we know that coefficient of friction is frictional force upon normal reaction force. Both are forces. So it is dimensionless, unitless quantity. Clear? So if in the question somewhere you are asked mention a quantity which is dimensionless as well as unitless, so you can answer either friction or refractive index. While a quantity which has dimensions as well as unit, that is the quantity named, yes, angle, because angle does not have dimension but it has unit, that is radian. So come to the question back. This is 10 Newton. this is 10 Newton, but the coefficient of friction is 0.5 Newton, right? So, frictional force between the wall and the block F will be mu into N. Now, I am again explaining you the dynamics, mechanics behind this whole force world. If you are pushing the block with 10 Newton, the block exerts the force 10 Newton in order to move in this side on the wall. So, wall will react to the block with equal force. Again, listen to me. If I am pushing the block towards the wall by 10 Newton, so block pushes this wall with the 10 Newton force in perpendicular left direction because it wants to move in the direction of force. But wall is there, so it will not be able to move, and wall will react on the block with equal force. So the normal reaction force in this case, carefully understand it, children, it is 10 Newton is the normal reaction force, and I am writing the normal reaction force here with the symbol R. So I am correcting the symbols here, mu R, because normal reaction force frequently is represented with R as well as N, right? So let us calculate the frictional force here. Frictional force will be 0.5, that is mu, into R, that is 10 Newton. So frictional force in upward direction is actually 5 Newton. So gravity is pulling the block down by 10 Newton, while the frictional force can have its maximum value. Always remember, this is maximum possible value. This is maximum possible value a friction can attain, maximum possible value friction can attain between the two surfaces, given surfaces. So it is, always remember, it is the maximum value of the friction between the two surfaces which friction can attain between the two given surfaces. But if required, friction will adjust itself between 0 to this value at any value just to keep the block at rest. And here the maximum value of friction is 5 Newton. Friction cannot attain more than 5 Newton value, but gravity is pulling it with 10 Newton force. So is equilibrium possible there? No. So we will write here that friction is 5 Newton and upward direction. Gravitational force or weight is 10 Newton and downward direction. So we will write that friction is less than the gravitational force, right? So equilibrium is not possible. Equilibrium is not possible. Is this concept of the case 1 clear to you, children? carefully observe the whole discussion and I move to the next one. What is the next one? Next one, let me take the 20 Newton force with which I am pushing the block towards the wall. So, what is the normal reaction force of the block? 20 Newton. Right? Now 20 Newton is the force with which I am pushing the block towards the wall. 20 Newton is the normal reaction force which wall exerts on the block, and the frictional force between the two surfaces. It is mu r. फटाफट कैलकुलेट कर ले. 0.5 into 20 न्यूटन. कितनी वैल्यू आई? 10 न्यूटन. तो क्या लगता है अब क्या होगा? Now frictional force, I will write here, friction is 10 Newton in upward direction. Gravitational force, that is weight, is 10 Newton in downward direction. Since F is equal to, and this is weight, so net force, F net or resultant force, which is gravitational force which wants to pull it down, minus frictional force which wants not to let it move, which is 0. So, block remain at rest. Clear? Case 2 is clear. Now let me take the third case and I am pushing it with 30 Newton, or say 30 Newton, yes 30 Newton. I am pushing the block with 30 Newton, so the normal reaction force R will also be 30 Newton, right? Now frictional force is mu R, that is 0.5 into 30, that is 15 Newton. क्लियर? चलो फटाफट फिर से एनालाइज करते हैं. फ्रिक्शनल फोर्स 15 न्यूटन, ग्रेविटेशनल फोर्स 10 न्यूटन. दिस इज द वेट. अब क्या होगा? क्या ब्लॉक ऊपर चलने लगेगा? नो, नेवर डू दिस ब्लंडर. This is maximum value of friction. This is maximum possible value of friction between two surfaces. But actually friction needs only 10 Newton to keep the block at rest. And what is the role of friction between two surfaces? That it does not want the two surfaces to move. It wants the two surfaces to be together, sticked together. So this is maximum value, but in this case, this is something very important. Here, F equal to 10 Newton is sufficient enough to keep the block at rest, or to keep the block and wall together. So why should the frictional force go to 15 Newton value? It will not. So here frictional force is friction between two surfaces. Here friction between two surfaces will be 10 Newton. To keep the block at rest, only 10 Newton is required here, not more than that. Are you getting this point? So what happens when such type of question is being asked, that what is the frictional force between the two surfaces? तो बच्चे क्या करते हैं, म्यू एन कैलकुलेट किया, 30 न्यूटन आया, फट से लिख दिया 30 न्यूटन, 15 न्यूटन आया, लिख दिया 15 न्यूटन। बेटा फ्रिक्शन इज सेल्फ एडजस्टिंग फोर्स। अगर 10 न्यूटन काफ़ी है ब्लॉक को रेस्ट पे रखने के लिए, तो फ्रिक्शन बिल्कुल भी इससे ऊपर की वैल्यू पर नहीं जाएगा। तो फ्रिक्शनल फोर्स इन दिस केस इज 10 न्यूटन। यहाँ पे ज़्यादा है उसके पास पॉसिबिलिटी कि वो इससे ज़्यादा फ्रिक्शन रख सके, पर वो 15 न्यूटन तक नहीं पहुँचेगा। क्लियर हो रही है बात? ये तीनों केसेस बहुत ध्यान से स्टडी करो, और तुम्हारा जो रजिस्टर है, नोट्स रजिस्टर, वो बहुत मेंटेन होना चाहिए, क्योंकि इस तरीके से न्यूटन्स लॉज का जो स्ट्रक्चर मैंने प्लान किया है, एक एक पॉइंट को स्टेप बाय स्टेप आगे बढ़ने का, वो तुम्हारे पास रिटन होना चाहिए, क्योंकि तब तुमको ये बहुत इजी लगेगा चैप्टर। और सिर्फ क्लास लेने से वो चीज़ तुरंत दिमाग में बैठती नहीं है, यू हैव टू गो थ्रू इट अगेन। सो मेंटेन योर रजिस्टर इफ यू रियली वांट टू डू वेल। नेक्स्ट क्लास, इसका एक और इंटरेस्टिंग कॉन्सेप्ट,